I am super excited to be here. I actually want to thank Ada and Lisa and this whole team because they pushed me. I've been working on this research for a few years, on and off, and they pushed me to really bring the digital and the kind of technical aspect to it for this conference. And in doing that, I was pushed to research and update my research. And what I found is just so exciting. And I can't wait to share it with you guys. So, I realized that I titled this The Evolution of Architectural Technology, so I should probably do some homage to evolution here. So I will actually start with a very kind of rough and quick example of how architecture and its technology has evolved. So originally we were building things out of what was nearby. We're talking thousands of years ago. Whether it's mud huts, tents, cabins, wood, whatever was available, igloos. And that went on for quite a while. Then eventually we got to, the classic age, right? We got the Romans, the Greeks, the pyramids, and this is the first real architecture in the world. There was an advance in technology there. It was one of these large jumps forward. It was massive. But it was also dedicated to the spirit world and connection that people have to something greater than themselves. And that's something that was continued on in the Gothic period. That's what I would identify as the next kind of major technological advancement of a very large scale in architecture. We had the flying buttress, we had really going higher, lighter, but still very limited. It was basically stone. Then, of course, the next major change that I've identified is the Industrial Revolution. And the biggest change with this, besides the fact that we had steel, we can really go up, it became more about the people. It became about not religion and not connection to spirit, not connection to something greater in another world. It became, okay, where are you gonna live? Because you're all moving to the city and you need a place to work. So it became very pedestrian, or at least not about, the idea of ornament and celebration started to go away in architecture. Now, the next kind of major shift I would identify as the modernity. And there it really became about the clean lines, minimalism, less is more, all about efficiency. What is going to create the most profit, essentially? Not that modernity is supposed to be about that, but it was really about streamlining. It was about making something that everybody can access, that is affordable, that is meant for everybody. And, come on. So then the next kind of major shift, and this is, we've gone through the entire history of architecture here. So the next is the computer, right? So initially the computer brought about AutoCAD, which was the same thing they were already doing by pencil, but now you could repeat yourself really easily, and you lost the sense of scale. So there was about a decade that we created a lot of really horrendous buildings. But skipping forward, what it did enable us, once the computers were harnessed and we got the programs that were really able to allow us to do something that we'd never done before, right? We were able to make blobs. We were able to make something that looked like anything we could possibly want. And we have one of the greatest icons of this right here in LA. But the question is, why? So yes, we are bringing back ornament and decoration and a kind of a celebratory nature to the architecture where we are applying these new technologies. And this is, I would say, brought about, and it's really kind of the bringing back the ability to decorate. Because through modernity, and ever since the Industrial Revolution, it's really been about eliminating that, efficiency, eliminating costs, what can we get out to the masses? And now with digital fabrication and computer modeling and the ability to, due to these new technologies, actually execute on these ideas without necessarily the costs going up. It still does some, but as the technology is continuing to move forward, it will be arguably just as expensive, if not cheaper, to custom fabricate or print a one-off building or components for a building. And the ability to make something unique without costing 15 times as much is really happening now. But the question that it begs to me, and this has bothered me for years, is what is the point? If it's just about making something that looks cool, then there's a limited market for that. There's a limited amount of good that this can do for the world. And really, architecture is, well, I can give you the hard facts of, most of the pollution that we generate, most of the energy that we use in the world, it goes into the buildings. It's either in the building materials or in the usage of the building. So this is, for example, a building that was modeled after a biologic system. It was made by a biologist turned architect. So this is another kind of fun-looking building, has a cool perspective thing going on, but it's cool. That's it. Then there's also a lot of decoration that's happening. We're using the new skills to fabricate or print or laser cut or whatever it is, and it's to make decoration. And what I really think we need to look at, and what I think the world is calling out to from us, is, okay, how can we utilize buildings that are doing so much, taking so many of our resources, and allow them to actually help fix the problem? And to view buildings not as a box that you go to work or live or whatever it is, but actually as a component within an ecosystem. So the building itself is more than just the building. It is something that is optimized for its users, for its site, for its culture, and it plugs back into the city. So it is actually viewed as a resource in a natural system. So this is kind of odd, right? It's, how can we really do this? Because biomimicry is a lot of different things right now. There's biomimicry that is just like this. I chose this picture because somebody wrote, evaluated this picture and said, oh, this thing is amazing. And they go through and they list what makes it so amazing, but none of it has anything to do with creating an ecosystem and being part of something greater. And I think until we can actually get our buildings to be viewed and designers to think in this way, we are going to be stuck and making lots of cool looking things. So this one here was, it was a student project. So this is an example of kind of what blob stuff we can make that's sculptural, and it's not really necessarily sculptural because it functions better. It's sculptural because it looks cool. And this, their biomimicry was that they were using, they're modeling it after fish bones and so forth, but what does that really do to benefit anybody other than it's a departure point for a conceptual idea? So what I think is exciting about what's about to happen is we can actually now take the computers and think about how we can use the computers to model the buildings to actually benefit everything in them and everything around them. So this is a diagram of how you could form a roof near the ocean, because we all know that there's ocean breezes. They're fairly minimal, a few miles an hour, but in the morning they're one direction, in the evening they're the other. So this was a project that I did a couple of years ago, and it was designed to say, okay, let's take funnels from one side to the other and just interlock them, and hey, now we can focus the wind morning and night, put it through a generator. We actually have enough wind power when we focus it that we can actually harvest it. So now the shape of the building is beneficial. Since we are already able to build anything, might as well do something useful. This is another, just a little more elaboration on the project. And I think I'm running out of time, so I'm not going to go through it, but in the breakout I can do that. Now, we can, of course, talk about what's really coming next. But in order to give a context to that, I want to go through a very quick example of what a design process looks like currently. And that's even using some of our current technologies. So this is a case study of this reuse of an old building. So this is just diagrammatic study. So they were doing, looking at, okay, how is the sun hitting this? How much energy is hitting it? Are we taking on a lot of solar heat? There's a whole lot of analysis that we have software that can do. And then we can go through and look at, are we supposed to, if we tilt it a little bit on the north or the east-west axis, how does that actually affect how much sun we're getting hitting it and so forth, efficiencies. But we're still going through a ultimately analog, human-based design process where it's still somebody that's taking what they know, rules of thumb and basic knowledge, and applying it to the idea of architecture and twisting and forming the building to be as optimal as we think it can be. But it's all originating within kind of the limits of the human mind and the time that you have at the office to work. So these are just some more studies. I'm going to skip through them. This is the red one was the original. This is their new scheme. This is how they can study the courtyard and how much volume is in it, et cetera. But these are all, they start with the human saying, okay, do this. Now we'll send the computer to analyze it, and we'll figure out at least how much energy we'll be using each year so we can predict it. And we can maybe see where a problem area is and optimize it. So there's a whole lot of studies we can do to optimize what we're thinking of. But I think what's most important is that architects look at design as a natural process, or at least look at how nature, quote unquote, designs. Because everything that we hold up as these amazing things, we still don't know how the details of nature really truly evolve. Like, we have a theory of evolution, we all basically buy into that. And that theory of evolution, where you try random things to see what works, and you have kind of genetic fitness, that is what we can now apply to architecture. So the flower looks the way it does because it functions, is a result of its context. For example, the giraffe, the whole theory of, well, the one with the longest neck ate the most leaves and survived the longest, so they all ended up with long necks. But, what about this option? We just, it didn't happen that way. But the way it did happen worked really well. Although they may be going extinct, who knows? So if nature designed buildings, or rather, if architects thought like nature when they were doing it, we would have an iterative loop to generate something. So we would come up with a concept, and we would put in variables, basically benchmarks, and allow the computer to figure out the optimal solution for us. That's really powerful stuff, especially because that software is now out there. It just came out, and it's actually functional as of just a couple of years ago. And we're getting combinations of software that are just phenomenal. So we can look through, this is a list of some of the basic softwares. And, if you don't know what these are, I'll go through the very basics. Rhinoceros is a basic 3D modeling program that is very ubiquitous. It allows a lot of power in non-orthogonal sculptures, basically complex curves, wonky shapes. Grasshopper is a plugin for it that is very popular. It allows for scripting of repetitive procedures, essentially. It's kind of like applying algebra to architecture. Advanced algebra, where you have equations and so forth, but it's very graphically simple. And then there's some sort of genoform application. One that I like is Galapagos, named quite nicely. Then there's also, you put in an environmental analysis program, which there are a few of. And when you string all these, you stitch them all together, you actually can create a feedback loop. So what this does is, let's see, how do I press play on this? There, somebody else is doing it, that's great. So this is an example of a video showing this process. So all these flashes are different ways of solving an equation, essentially. You put in your variables what you value, and it eventually works its way out through genetic algorithms in a fitness model. So you can now create the optimal building for, in that case, it was for solar, that was for views, I think, and this next one's for solar irradiation. This is an even shorter video, which, again, needs to be started. Is it the same one twice? No. Okay, this next one's the view optimization. So a similar thing, it's only 11 seconds. But this is about saying, okay, I've got some monuments that I want to look at for my building. I want to provide views to something important. This program will help me optimize the views out of the various rooms. Now this is a little bit longer. This one has the sound on. This is about 2 minutes or a minute and a half or so long. And this actually shows a skyscraper being generated through this process. I'd like to let you watch this, and then this is basically the end. So what is happening here is, one, it's figuring out the best locations for the various towers. They've decided to make it multiple towers, kind of like French fries sticking up out of the ground. So this is a video that they put together. This is somebody's thesis, essentially, saying, hey, if we can make the world, make these buildings and prove that it is more profitable to go through this way, then developers are more likely to do it. So this is a full analysis saying, this is an idea, this is a visual of how these things are scripted. When I said it's kind of visually nice algebra, that was actually a screenshot of it. So here, now it's moving around where, it's deciding where the best locations are based on distances and proximities to whatever they deemed important in that site. Now it's, again, configuring more of the towers and so forth, and then this is showing it going from very inaccurate to, as it went to the right, it really narrowed down to a final solution. Now it's continuing. You can see this graph growing, and it's going through a few operations. Now it's going up, the height of the building. And this is this concept of building and designing as something that we are controlling by controlling what we value, and then deciding amongst the outcomes what is most useful to us and what is best for the client, what is really best. But there's so many things in the world that architects are responsible for. We've run out of the capacity for a single person or a single office to really go through every option. But now we have the computer that can do it again. And this is, I would say, it's the next major shift in architecture, like I was outlining at the beginning. The future is going to be very different from what it is now. The way that we view buildings is going to be entirely different. In 20, 30 years, we'll be building buildings like this. Right now, it's being taught in the schools. There are courses being taught along this way, but I was trying to find examples of actual built work, and it's all so new. There really, to my knowledge, isn't any yet. This is the beginning, and it is just, at least to me, as an architect, just incredibly exciting. So here now it's going through and optimizing all of the units within each floor of the building, making sure that where the hallways work, optimizing it all for fitting it into the geometry that's already optimized. And ultimately you end up, here it's saying the views and the units, and it's really taking you through. This is as close as I could find to something that's actually developed with this. And there's your view of how this skyscraper would end up looking. Now, I can't speak to exactly what variables they were putting into this to generate it. This is more to illustrate the power that is here. And it is up to us as architects and a culture to call upon the architects to value things that are important to this world, because so much waste comes from architecture. We have the power and we need to use it, and I need you, the people, to hold the architects responsible and hold the developers responsible, because this is what can be the future. It will be to a certain extent, but the more support it gets, the better. And we have this amazing opportunity. And I hope that I am able to give you with this a little bit of the wow from the last presenter there. I hope that I can help you see that this ultimately is very simple. And the future is going to be super exciting. And in the breakout session, what I have prepared, I have an assistant here who took about 4 hours today and put together with software, some of these softwares he didn't have before. And he immediately was able to jump in, and we were able to create a rudimentary building just this afternoon. And I want to be able to show it to you guys and walk you through it and really go through this process in a 20-minute process. And really, for those that are excited by this, I would love to share it with you. And lastly, I just want to point out that I only had 20 minutes. There's so much more in technology and architecture, especially on the building side. We're also on the cusp of actually printing buildings. There are people already doing it. It's not cost efficient yet. It's very kind of out there, but it's coming. And the world of architecture is just gonna blow up. So if you want to, come take my breakout session. I can't wait to share more with you. Thank you.